Hello, my name is Stephen Bauer. I'm going to be doing our midterm presentation. My group mates are Suparno Pal and Chandan Kumar. Our project is the RF-based respiration monitoring system. So first I'm going to go through and talk about the overall project goals and the specific aims and what we're really trying to do here. So the basic idea is that we want to determine a person's respiratory rate using RF signals on the Pluto SDR. To do this, of course, we need to write scripts and models in MATLAB and Simulink to modulate and demodulate the message signal, and we're using a 2.4 gigahertz carrier signal. We also need to develop models linking respiration to phase and amplitude related changes in the RF signals as they propagate through the channel. Then we need to use some signal processing blocks and techniques to extract the information that's related to the respiratory rate from the demodulated IQ signal. And finally, we need to verify our results. We need to see if the project is working. So we're going to do that by counting the breaths that the patient takes during the experiment and comparing that to our results. So then there's a couple of improvements and exploring potential applications that we want to talk about. We want to explore some improvements to our experimental setup because that sometimes introduces problems. And we're going to do this by using the concept of Fresnel zones. We also want to be smart about the way that we do signal processing and peak detection using thresholds, and using some smart improved envelope detection techniques. We also want to potentially explore model phase related changes due to respiration, and finally explore the applications of our work and how we could, make something useful to the real world and society with this type of work. So now I'm going to get into our technical approach. We're currently using this technical approach that was in the We Breathe paper recommended by the course staff. I'm just going to go through really quick and show you what our experimental setup looks like. So in the first block there, you can see the transmitted signal. It's being amplitude by the expanding and contracting chest of our patient. And this is the amplitude modulation of the message signal, of course. Then we receive this amplitude modulated signal in the baseband in number 3 there. Then we do some envelope detection in block 4. We downsample in block 5. And then we determine the respiratory rate. And here we've listed some different ways of doing that, and we're still sort of trying to figure out what the best way to do that is. Maybe FFT, maybe temporal peak detection. There's a couple others. We're trying to figure out what the best approach is there right now. And of course, we're developing our own scripts and models and writing our own code and using some of the built-in MATLAB and Simulink functions. Okay. Our current status is that we have written a MATLAB script for our SDR-TX and implemented the RX model on Simulink. So, I'm just going to kind of take you through where we're at. A 10 kilohertz sinusoid signal is transmitted on that 2.4 gigahertz carrier, reflects from the human body, and is received by the same Pluto. The amplitude of the baseband signal is reconstructed from the square root of I squared plus Q squared of the demodulated signal, and modulated due to respiration is observed on the time scope. So we can see that modulation happening from the person breathing. And then we've also implemented a preliminary filtering envelope detection block to extract the envelope of the signal, which could be processed to obtain the respiratory information as well. As you can see, that we're still having a little bit of trouble with the envelope on the right hand side, but on the left hand side, this is the real-time signal And here you can see when the person breathes in and out, you can see that message signal being amplitude modulated by the chest expanding and contracting. So that's a very encouraging result. We're very happy with that result because we can, that means we've done the setup correctly, and we can see some good initial data here. So the next steps in this project are implementing the sliding window based FFT method to estimate the respiratory rate from our envelope after further downsampling. We also want to implement a peak detection method to estimate the respiratory rate from the envelope. And this was the advice that we got from the core staff in our separate meetings, and that was very helpful. We did really appreciate that. Again, we need to verify the accuracy of our results based on our initial idea. It seems that this is, that signal that I showed in the previous slide was being clearly modulated by the person breathing, and we'll also upload a video that proves that, or that shows that at least. And so that's again very encouraging. But we also want to explore improvements to our experimental setup and these Fresnel zones, and we also want to model the phase change based on the phase to estimate the respiratory rate. And finally, I guess also explore the applications of our technology, make sure that we're, maybe have at least one sort of case study where we can see that, this type of technology would be helpful to somebody or marketable in some way. Yeah, thanks again for listening to our presentation, and we're excited to make these improvements, and we feel very encouraged that we've been able to get some good preliminary results here. Thank you again.